Okay, good morning to Dr. Zahirul Islam and my fellow classmates. Today we are from Group 10 going to present a planning of the installation of rooftop photovoltaic installation at the UTSM campus was located at Baik Raja, Batu Pahat, Johor, Malaysia. Okay, next. Okay, and this is our team. I'm Muhammad Afiq Irfan bin Azaly, and today with me is Aqil and Tharnisha, and we are sorry to say that Huda couldn't join our presentation today because due to some reason. Okay, first of all, we know that Malaysia is our country with a tropical weather of hot and humid throughout the year, with particularly have temperature in the range of 31 to 32 derajat Celsius. Therefore, Malaysia will know for electricity generation from solar energy, and their average daily sunshine is from 4 to 8 hours, which is sufficient for solar panel to absorb power from the sun with a daily solar radiation of 4,000 to 5,000 watt hours. In conjunction with that, photovoltaic cells have the physical characteristic of semiconductor that is not in the solar technology. Okay, the main goal of this project was to implement green technology and gaining sustainable development through the installation of rooftop solar photovoltaic, which also known as system that generate electricity from the solar panel installed on the roof in the building meant at public institutions such as UTSM. That's not only help to achieve government intention to boost renewable energy sector in Malaysia, thus reducing their moon electricity bill. Okay, for our scope of study, my group was still focused building at the main campus, building such as level 2, Tunku Tun Aminah Library and Sultan Ibrahim Hall to do this project. Okay, next.
So for this case study, we had made meta-analysis to the installed capacity from the year 2010 to 2020 and the electricity generation from the year 2010 to 2019 of solar photovoltaic energy in Malaysia. So based on the analysis made, it can be observed that the installed capacity and also the electricity generation also increases every year, and it shows a positive linear regression line. Next. So as shown in the data slide, we obtained the data of total energy usage in the main campus, and it can be said that the total energy consumption was 188,19610 kilowatt hour with a total cost of 6869158 ringgit Malaysia. So, and we can see the least cost of the monthly bill was on April 2020 and the highest was on February 2020. And it can be seen that the higher the energy consumption, the higher the electric bill is. So therefore, we recommend of installation of rooftop photovoltaic in the main campus that can reduce the monthly electricity bill. Next. So for both the buildings, the total surface area covered was 135,219.5 feet square for the photovoltaic installation, which shows the total surface area of PTTA is 63794.2 feet square and also of 71425.3 feet square. This installation consists of 1751 units of PV modules for PTTA, while 2,282 units for DSI. Next. The main component used in this process was multi-crystalline solar modules with an output range of 320 to 340 watt for per solar module, solar inverters, solar charge controllers, and also solar photovoltaic battery storage. Next. The Gantt chart in the slide shows the methodology phases in the case study. Firstly, in define and planning phase, the process involved was survey regarding the topic and also identifying the main objective of the project. And also the scope of the study, background study, selection of suitable software such as Helioscope was done during the phase. Next, in the second stage, the related data was collected regarding the buildings. And also in this stage, the proper design was also analyzed and also studied further. Next, for the designing process, we have gone through the Helioscope software in order to estimate the needed rooftop photovoltaic modules, and also estimate the return of investment. And finally, in the verification and reporting process, we have done the full report after the verification from the team members and also the finalization of the project. Next. Can I get?
Yes, can Akil, can. Okay, thank you, Tharnisha Group. It's a good presentation. Okay, you got a good presentation, very good, and excellent meta-analysis. Especially, I like it that how you relate that actually why we need the solar, right? Because of the demand, electricity demand, and the energy consumption. It's excellent linkage to this project. No? So this is actually we call it the actual meter data analysis. For NEM, net energy metering, I have seen that this question is for Tanisha. So you have shown the picture of batteries. Okay, do you think we need battery for NEM system?
Battery for if in case we didn't enough of solar energy, doctor.
I mean, for the backup, right? You're saying.
Yeah, doctor, for the backup protection.
No, actually, yeah, that's good. You say is what you say is good, but that is basically we use battery for off-grid system. Enemy is a grid connected. Okay, enemy system is a grid connected system, so it means that we will sell the electricity to the we will sell excess electricity to the grid. So grid will pay me back. So that's why in enemy system we don't use any enemy. Sorry, we don't use any battery. We don't use any battery. But if it is like an off-grid system, like your system is not connected to the grid, totally depend on the solar energy, then you need a battery, because you need to generate electricity. You need to get the electricity at night time, right? But if your system is connected to the grid, at night time you can get electricity from TNB, no problem, right? Or maybe let's say in a daytime, if there is a cloudy day or rainy day, your PV cannot support your load. So in that case, you can get electricity from the TNB, okay, for grid content. But if it's off grid, then that means your system is not connected to the grid. So in case it's a cloudy, you have a load, okay, it's a cloudy day, or at night time. So how you will get electricity? You need to have a battery then that for that system. Okay, good, very good. Then after that, tadi siapa? Aqil tadi present. The costing siapa present? Aqil ke? Aqil ke Alif?
Aqil.
Afif, sorry. Huh? Okay, nice. Yes, nice. So your total installation cost how much for DSI? Untuk DSI, for DSI. 1.7, 1.8 lah, like this. Okay. So what is your proposed capacity for DSI? The solar capacity. I mean, what is the capacity of the
Proposed capacity for DSI is about 28 kilowatt power, doctor. While for the PTTA is 30.
No, I think more.
Oh, the system size is it, doctor?
Yes, yes, system size, yes.
Okay, system size is for DSI is 730.2 kilowatt power, and for the
Okay.
PTTA is 560.
Actually, kilowatt P stands for peak. It's not power actually. This P stands for peak. Peak means actually maximum. When the solar irradiance is a 1000 watts per meter square, that means the sun is very bright. Okay. In that time, your system can produce 732 kilowatt. P, you see the small p again, the bawah, right? At the down, right? Yeah, it's a peak, P-E-A-K. It stands for peak. Okay, it's not power, yes, because it's a kilo. It's actually power. It's a system size. Is unit is power. The power is actually the unit for power is watt, right?
Yes,
Unit for the power is watt. So that's why actually it is 732.2 kilowatt. Okay, and P, the small p stand for peak hour. So this is the maximum you can get. If there is a less sunlight, then you will get less than that. So you will not get more than 730. That's actually your. So how did you calculate it?
We use the NEM calculator, doctor. NEM calculator.
Oh, the online calculator. Okay, very good.
Yes, doctor.
Okay. So now you tell me what is the cost per kilowatt? Cost per kilowatt. Berapa ringgit untuk 1 kilowatt? Faham kan? Senang je kan? Kalkulator senang. Alamak, I tak nampak. We cannot see Aqil. Later on, if I jumpa dekat Aqil di luar, I don't know actually who is Aqil. Oh, yes, true. It happened for me if I record at the same time or share the slide, then I cannot turn on the video. I don't know why. My question is, for 730.2 kilowatt, I need 1.7 million kan tadi. So I want to know if I want to pasang 1 kilowatt, 1 kilowatt, how much money I need? Berapa ringgit I can invest untuk 1 kilowatt? So itu
dia ada 10 barang. Ni ada 10 item. So kena ambil satu-satu je kira.
tak payah. It's very easy. 1 point tadi berapa? 1 point
It's 2,000 plus, doctor.
2,000 plus. 2,000 berapa ringgit? You put the 2.8.
2,460 ringgit per
2 point, so you got 2.4K lah per.
Yes, doctor.
Okay. It's actually quite cheap. It's quite cheap. Because if you invest this much of money to, this 2.4K is tak masuk you punya gaji semua tak masuk.
Only gaji tak masuk, doctor, and then the others all included.
Such as?
Buruh tak ada.
I mean the installation costs, construction costs, maintenance, everything.
It's quite cheap. Actually, 2.4 square it has to be at least like maybe 3K, right? At least 3K. But it's okay because your gaji tak masuk, so gaji separately you claim. So still boleh terima lah. I can accept it. Okay, the cost, because maybe you just how did you get the cost? It's my another question.
Cost for the module, is it, doctor?
No, yeah, you got 1.7 million, right?
Oh, okay, doctor.
How did you calculate?
For the solar modules and then for the inverters, we got the data from the helioscope, which they will give like 25 inverters and then how many solar modules. So we check for the cost in the online website, doctor, for the prices.
I see. That's why. Actually, no, 2.4 is fine. Of course, you can make it. Of course, you can make it. But macam really tight lah, you will have less profit lah because the tax, other things is not included. That's why, because you check from the online, right, the website. That's why you got this like very accurate, cost. But usually, if you tell any like in Malaysia, if you give to any company to do it, they will ask for like 4,000, 5,000 like this per kilowatt.
It's like for the modules itself, doctor, it costs like 700 plus.
I mean per module.
For the PV module, per module is 700 plus.
What is the capacity? 700 what ringgit?
Yes, doctor, 700 ringgit for per module with 320 watt.
Oh, it's very cheap.
Because it's a Trina module, doctor, which is the new one.
The Trina, the UTHM use the Trina module.
Yes, sir. It's multi-crystalline module one.
Yes. Oh, the type is multi-crystalline, is it?
Yes, sir. The PD14 module.
Okay, good. That's why actually, because I think it's good. It's a very good analysis. By the way, I have another question, but I'm taking much time. ROI tadi Aqil cakap, actually I am asking Aqil sebab Aqil yang presented tadi. Tapi I nak tanya Afif, Afif lah, Afiq, sorry.
Ha.
Afiq, ROI tadi Aqil cakap 8.2 tahun, 8.2 years. How did you calculate ROI?
ROI.
Return of investment.
Yang mana?
Tanya Aqil lah. Yes, in the conclusion, I guess. I tak cakap, you guys say. So I'm just asking question.
Oh, how, kenapa dapat ni 8.2 years?
No, bukan kenapa, macam mana? Tahu ke macam mana? You can ask Aqil maybe.
How you get? Okay.
Atau dalam report you mention ke? I don't know. Maybe in the report you mention. I didn't check your report, you guys. Inshallah, from next week I will start marking. And after I do the marking, I will return to you. I will upload in the author. Then you can see your mark. You can see the comments. Semua lah. So guys, if by the way, if you this is announcement for all. If you still doing your reports, so finish it by Thursday. Okay, please finish it by Thursday and upload it. Okay, I still can accept until this week Thursday, but not after Thursday lah.
Divided profit.
No, it will not be like this. Later on you check. Later on I will tell you what is the formula. This is not the formula. Okay, ROI formula, later you check. Actually it should be your cost of investment divided by how much energy you are, how much the value of energy you are getting, not power, energy. Bukan power tu watt kan, you need energy tu watt hour kan, betul kan? So you need to calculate that one, that actually from 730 contoh untuk DSI, right? If I only take DSI, from 730 kilowatts peak, kilowatt plus, so you need to convert it into hour. Okay, I need to convert to hour, so you can just times by 4 actually in Malaysia, because sun hour is around 4, 3.8 to 4. So convert it to times by 4, then it will be in kilowatt hour. So now you need to check what is actually SEDA is giving for 1 watt hour. SEDA is giving, because SEDA has a specific price for this energy, because this much of energy you will get, right? This much of energy you will get from the solar. So 1 watt hour, you need to check from the SEDA how much website, then you can times by this. Okay, so that will be your daily watt hour. It's like this. Okay.
Okay, thank
This
you,
is like it's approximate. Then that value you have to divide it by your punya total investment. Then only you will know what is your return of investment. Yes.